welcome to the data structure course, and today we will be discussing very important topic that is called linked list. So this topic is very important from gate exam perspective or competitive exam perspective. So let's start. Before starting, let's see how a variable is being declared in the programming language, right? So say when you are doing int, when you are writing int a, right? That means you are telling to the compiler this is the data type, integer is the data type, right? And a will be the variable which is going to store this type of data. Now imagine if I need something like this, means I want to store data also, right? And say address also, right? Or data means if I want to say integer data, right? Or character data combinedly, right? So there is no predefined data structure already available for it, right? But we have provision of making a structure for ourselves, right? So that is being done by struct keyword, right? So if I want to make a type like this which store data, so say integer data and character data, right? Character data with it, right? So what I need to do, we can do our own data structure, means we can create our own data structure. Name, say I am naming it alpha, right? Struct alpha, it is having integer data type, right? So I will name int and say head, and then I am saying other second block it will take character, and then it is tail, right? Right. So I'll name it as IC, some name, right? So this is how we can declare a structure, right? So now coming on to the linked list, right? This is the very basic of structure. Moving forward, I will be explaining it a lot, right? So say in linked list, what we try to do actually, say when we are writing, say when we are writing an integer, say 5, right? And I have another row or other column in same data block which will be pointing to another memory structure, right? So say this area is at 2000 memory address, right? And then I want, I have another memory address that is at 4000 and it is having some data, say 6, right? And I want to link both of them, right? That is how it is called linked list, right? So remember, in previous arrays, in previous lecture I have covered arrays, right? So in that we have continuous memory, right? 5 6 4 3 2 9, like this. And then we can access like 0 1 2 3 4 5. So if I name it a, then a of 1 will give us the address, right? In here we don't want, means it is not possible every time to get continuous memory allocation, right? So say some memory chunk is available at this place 2000 in memory, some hypothetical memory location, right? Some is at this place and I want to utilize all these chunks. Some place I have taken this 9 and it is at 5000 place, right? I want to link them, right? So first what I need to say, I need to take, this is an integer and this will be linking to the another location, right? So I want to link it. So basically how will link, I will put at address part this 4000, right? So this is like data part, right? And this is address part, right? And when I write it 4000, this will get linked to this location, right? Similarly, this is its data part and this is address part. When I write 5000 here, it will get linked here, right? And if we don't want it to grow further, we can use the character null, right? This is very high level idea of linked list. I will be explaining it a lot. So this is how we can make a data structure or structure in a say. And in that, what I can do, I can take memory part, right? Oh, sorry, data part and address part, data part and address part. So first of all, I need to declare a structure out of it, right? This type of structure I need, right? So how I will make this, right? I will write struct, right? Say every these things, every these blocks, I'm naming it as node. Struct, this is name of my data structure, right? First part is integer, so what I will write, int, right? Say I will name it as data only. Second part is having address, right? And if you have seen first lecture of arrays, right, address is being stored in pointers, right? So I will write it as, say, star link, right? This is address. And which type of data it is addressing? Struct node type of data only it is addressing. This is called self-referential structure. This is self-referential, right? So if you don't know about pointers, right, I will just quickly I will tell you what I mean to say. Say if I have declared a variable int a, right, equal to 5, how it goes in memory, a will take some memory location, say 900, and 5 is in. So if I want to declare a pointer, how I will do, int star p, right, and p will take address of a, right? So internally p will take address that is, say if it is 900, so p will take 900, right? Now this is how we use pointers, right? So in here what I have done, when I am declaring a data type, say of integer type, so pointer also I am telling it will be pointing to a integer type, right? So that's how, when we are pointing to this type of node only, say this is node 1, this is node 2, right? So pointer should know which type of data I am going to point, so it is node only, right? So that's why this type of data, struct node is simply name of data structure, right? Like integer is a data type, right? So same thing we have done. This is this definition we have created for our data type, right? Our data type or our data structure actually, right? This, when we write it like this, it is equivalent to int we do, right? Int predefined data type. This will take integer type of data, our struct node will take this type of data and link type, right? So when I am doing int star p is already knowing that I will be pointing to integer type of data. When I am doing struct node star link, it means it will be linking to the this type of data only which I have already created, right? Node 1 is one type of data structure, node 2 is same, means different instance of same type of data structure. I think I have made it clear, right? So how we usually do it, right? So now this was like, this is the thing which I want to achieve, we want to achieve. This is how we declare a data structure. Now I will make it more clear to you, right, how to do it. Say if you want, if you are taking now struct node, right, and you are doing, taking a variable a, right? Now this a is of struct node type, right? This is the first concept, right? We need to remember this thing, right? I have already declared what is struct node, right? So this is the struct node, it will have integer type of data and star link, right? So struct node a will be this type. So if I am doing this thing, a equal to, right, or I need to do it here only. So if I am doing a equal to, say, 5 comma null, right? So what it will do, it will make a memory location this type of, right, like we declare int a equal to 5, same thing it will create, right, 5 and null, right? Now if I want to make one more instance, so what I will do, like this is int a, now int b, int c, similarly I will do struct node b. If I am writing 7 comma null, right, so it will create a block like this, 7 comma null, right. And if I am doing struct node c equal to 2 comma null, right, so this link is going to null, actually we are not linking it, so it will be 2 comma null, right. The way I am doing this thing will be created in the stack memory. I will tell you how to make these things work in heap memory also, right. So this thing will be created in the stack memory, right. Slowly I will let you know. So I will take 4 nodes, struct node say d, so it is having say 9 and null, right. So this is how you create a node of this. Obviously we have to declare. I will run a program also, I will write a program for this to make you more clear. Now you see this thing means we have created the nodes, right. Now I want to link them, right. So say hypothetically I am taking a memory address. Actually addressing depends on the type of system you are using, right. Every pointer will have same memory size, because it depends on the system addressing modes, actually, right. So this int star p also will be have same size of struct node pointers, memory allocation, right. That I will tell you. First we will see how to do it. Now if I want to link, say this is at memory location 1000, this is at 2000, this is at 3000, this is at 4000, right. Now I want to link, right, this node to this node. So what I will do, I have made the instance, right. Now what I need to write, a dot link. Link is already a pointer part, right. A dot data means if I want to read it, I will write a dot data. If I write it, it will give me 5. Currently if I write a dot link, it is null, right. Now a dot link, I want to link it to b, right. So what I will do, and of b, right. I am again repeating these things. The way I am writing, it will be working on stack memory. Stack is first in first out, means the time one function get executed, these all variable will get flushed out. So I will tell you how to do it in heap memory also. First we will see easier version. When we do it like this, right, so what this thing will do, this will put the address of this in here, and this is how these both of these things will get linked, right. Now if I am writing b dot link, right, so now what I need to do, and of c, right. So what will happen, b link part, it will get 3000 inside it, it will get linked, right. Now I am doing c dot link, right. And if I do and of d, and means we already know this is how we access memory locations, right. So say if it is having any memory address, say it is having 4000, so it will get linked to this position, right. So this is how it is being linked, actually, right. So to make you more clear, this is how it is being linked, actually, 2000, right. And then this thing is at 3000, right. And this thing will get linked to 4000, right. So this is how we create a basic linked list, right. So and if we want to print out, means this thing, right, first memory location, to access it, what I will do, so how to create struct node type of pointer, it is very simple. How I will do, I will write struct node star p, means this is the type of pointer, means this type of memory location it will be going to point, right? And what you will do, give it the first area's address, right? So first node is a, right? So what I will do in here, p is equal to and of a, right? Now it should be clear that the same thing, right, this thing, right? P is equal to and of a. So now what happened, when I have written p is equal to and of a, say p is a pointer at any memory location, it will get, this is the name, and this thing will have address as 1000, right? And this is a pointer simply, and it will start pointing at this, right? It will simply start pointing at it, right? Now if I want to access all these elements, right, so there is third concept in here. What I will do, p is having 1000, right? So if I do star of p, right, you will reach the value of 1000, fine, right? Star of p value at 1000, that is 5 and 2000. So how to segregately access it, right? So what I can write, this is what how we have declared. So how we can write it, we can write p, now it is like this, p data. This is shortcut actually in programming, right? You can access, if you do p data, it will give you value as 5, right? P link, right? So what it is, p link is value at link 8, that is 2000, right? Or any memory location, right? Means this will be having address, right? Now if I want to access further, right, so what I will do to move forward, so this is how, what it means actually, p data is equivalent to star p dot data, right? So that is also 5, right? So this or this is how star p value at this point, right, reach at this point and give me data, right? Usually we do use this, right? This is fast way to access it. Another thing, if you want to move forward in the linked list, now you need first pointer location only, right? So fourth point is p equal to p link. What it will do, it will move your pointer now from this location to this location. Now p will be pointing in this place, from this location to this location, right? And similarly we can access complete list, right? So I will give you very quick demo of it in programming language, right? I will be basically using firstly c, then I will show you demo in c++ also, and then in java, and then in python. So c, java and python I will be accessing, right? So let's move to the code base and see how what we have learned. So I have make a file struct node dot c, and I will doing hash, I will be doing hash include standard input output, hash standard input output library. Now I will be making my structure struct node, and this will be having two type of data, int data and then struct node and star link, as we have learned in the theory. So this is a data structure created basically. Now I am writing int main, and in main I will be taking struct node, and I will take one pointer of type struct node. I will tell you what to do with it. And struct node, I am naming it as a, first node. It will be having data, say it is having data as 5, and link part as null, means I have not linked it anywhere, right? So I will make 4 nodes quickly, a and then b, and then third node will be c, then fourth node is D, and then 5 4, right, 6, and then 566. Okay, some node. Okay, so some data, right? So what I will do now, like, I will be doing it, linking it, right? So a dot link will be having address of B, right? And then B dot link will be having address of C, and C dot link will be having address of D, and then D I will not be linking anywhere, right? Now P will be having address of first node, right? Our head node, right? From where our linked list started, right? Now what I will do, I will try to print out this linked list. Remember, this we are doing in stack memory. While I will tell you how to do this in heap memory also, right? First let us see P dot link, right? Because P is at first address, not equal to null, right? Not equal to null. So keep on hovering over the linked list and give me the value of printf, give me the value of every linked list data, right? So -t, this is for tab, and %d, since it is having integer data, p dot data part of every linked list, and keep on moving forward, p equal to p next, right? P link, right? And since it is main functions, I will not be returning anything, return 0, right? And run is complete. I will be running it. I have saved it, right? And now I run it. So see, it is giving 546, 546. Why it is not given us last node? Because we have checked link as null and we have exited from the loop. Means to make the print, to print the value of last node, you simply write printf out of this loop, right? That will make my point actually. So now if I run it, right, you see 5 4 6 and 5. So I will again run it, right? 5 4 6 566, right? So this is how we basically print a list, right? Print a structure actually in stack memory. The only drawback with stack memory is, with function references, I will not be able to access these values. Why? Because in stack, once one function comes, these variable will remain at the time of function execution only, right? When it comes out, it will not be available, right? So for that, we have heap memory allocation, that is with malloc, right? So that will be taking up in next lecture, because that is also a bigger concept. So this is what we have done, and this is how we used to run the program over it, right? So I think let's meet in next lecture, right? So if you want, I will put \n also to show you the list. You see 5 4 6 5 6 6. This is how it is being printed, right? So okay, bye bye, let's meet in the next lecture. Fine, bye. Then we will see about the heap allocations actually, that is being actually implemented, right? This is just to show what are the basics. Fine.